All right, guys, this is question one, and this is the jet landing, right? So again, we've got, a jet, Mr. Bergman's jet, boom, and he's landing, and he's coming with a speed of 71.4. So notice what I'm doing here is I'm diagramming everything. And he stops after 949 meters. Got it? So that's the problem. The question is asking for, assuming the jet lands down, find the magnitude and direction of the acceleration, assuming constant acceleration. So they're trying to solve for acceleration equals question mark. And then when they say that the direction, obviously since he's moving in the positive direction, the acceleration is going to be a negative answer. Does that make sense? Now to do this, we're going to need to use our equations. And so we've got the list of equations over here on the side. And as a side note, I'm not sure you've watched the video that introduces you to the 5 equations. These are the key equations in kinematics. These are the 5. Actually, I sometimes call them 6 and 7. This is a derivation. It's sort of similar to equation 4, so I kind of put them down here. It could also be in the y direction. That'll be when we learn about what we call the second dimension, so let's not worry too much about that. But the equation that we're going to use here to solve this problem, since we have an initial velocity and we have a distance, is going to be equation number 5. It's printed there, right? So it's going to be v2 squared equals v1 squared plus 2a delta d. D being the distance, a is the acceleration. And this, of course, is what you're solving for. He has an initial velocity, right? And he comes to rest, v2, right? Think about that. What is his final resting velocity? And you're going to be solving for a. Keep in mind this sign. That's how you solve this problem using equation number, whatever it is over there, 5. This is equation number 5. So you're going to find that this table over here, having this available, is going to solve your life. If you can figure out which equation to use, you have to kind of look through here. Which ones do I know? See, there was no mention of time, so most of the equations have time in them. Number 1 has time, number 2 has time, number 3 has time, and number 4 has time. And this is the only one without time. It's the one without time. That's why we're going to use equation number 5.